Perspective Class 6 Video 1. In this video we're going to talk about two-dimensional parametric equations of lines. So in previous videos we've spoke about how to write the equation of a line in the xy plane in the form y equals mx plus b, or in the form x equals some number. Well, the parametric equation of a line is just a different way of writing the equation of a line. So it's another way of describing the same sort of object. But parametric equations have lots of benefits, which the more traditional y equals mx plus b do not have, which we'll see in later videos. So let's look at the definition first. This definition says that an expression of the form a, b plus t, c, d, where t is a real number, describes a line in the xy plane. So this is a lot to take in and it looks really algebraic, but what's going on? This the curly braces means like I want all the points described within this set. So I have one vector right here, and I have another vector right here, and t is a scalar, and I'm doing scalar multiplication. So I'm saying you go to the point a, b, and then you add all the scalar multiples of c, d. Okay, that's what this t is a real number. So I'm letting t like run over all the real numbers. T is called the parameter in this parameterization because t parameterizes the line. As you vary t, you vary the point on the line. Well, this type of expression is called the parametric equation of the line. And this might freak you out at first because the word equation might make you think that you need to have an equals sign somewhere. But there's no equals sign in this thing. But that's okay. This is still what's called the parametric equation of the line. Okay. So in general, the general form of a 2D parametric equation is like this. So it's u plus t times v, where t is a real number. Okay, where u and v are vectors, two-dimensional vectors, and t is a scalar. But this is a lot to write, so sometimes we're just lazy and we just write u plus tv with the curly braces around the outside. Okay, and it's an abuse of notation, but it's just it's a common abuse of notation. So sometimes we're lazy and we just write this. Let's see an example of a parametric equation of a line. So right here, okay, it's in the lazy notation. The vector 0, 2 plus t times the vector 2, minus 3. I want to plot this line. So how do I do that? Well, I'll plot it in pink. The way you think about this is this vector here is like your starting point on the line, and this vector next to it tells you which direction to move in. So the first thing I do is I go to the starting point, which is 0, 2. Oh, okay. So the first thing I should do is label the axes. Otherwise, I will lose points on the exam. Okay, so now I can get points on the exam. So the first thing I do is I go to 0, 2. So that's 0, 2. That's right there. Okay, and I know that this point is on the line. And now I sort of travel in the direction 2, minus 3. So that's 1, 2, 1, 2, 3. This point here. And I know that this point is on the line as well. And now that I've got 2 points, I can just join them up. And I can extend it in both directions. Dot, 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 dot. So this is the line described by this parametric equation. Okay. Another way you can think about this is you think about plotting all the points as you vary t. So for example, when t is equal to 0, what do you have? Well, you just have 0, 2 plus 0 times 2, minus 3, which is 0, 2. Okay, which we have. When t is equal to 1, you have 0, 2 plus 1 times 2, minus 3. Which, if you work this out, this is 2, minus 1, which is exactly this point down here. Okay, when t is equal to 2, you have 0, comma 2 plus 2 times 2, comma minus 3. And if you work this out, this is going to be 4, comma minus 4, which is this point right here. Okay, and the idea is, you want to plot every single value for every single possible value of t. So you want to plug in every possible value of t, see what the output is, and then plot them. Well, you don't actually need to do every value of t, because I'm telling you the answer is going to be a line. So you only actually need to do 2 of them, like we did here and here. And then you join the line and you extend it. Okay. So this is just another technique for plotting the parametric equation of a line. You can just plug in a couple values of t, get the corresponding points, join the line between them, and extend it. Okay. So let's move on. Why do people care about parametric lines, and what's so special about parametric lines? Well, parametric lines have a lot of benefits. They have some downsides as well. Like, one particular downside is the parametric equation of a line is not unique. Okay, i.e. there are many different parametric equations which describe the same line. So if the question asked you to calculate a parametric equation for a given line, there's not just one unique answer. In fact, there are infinitely many correct answers. Okay, so this is arguably one downside of parametric equations, in that they don't give you a unique description of the line. Let's see an example of this. So this example tells you to find the parametric equation of the line in the xy plane that goes through the point 2, 3 and 5, 1. So maybe let's try and solve this geometrically first. So what I mean by that is, let me draw some coordinate axes. Okay, -1, -2, -3, whatever. And I'm just going to plot these 2 points. Okay, so 2, 3 is up here, and 5, 1 is there. And I want the line that goes through these 2 points. So I want this line here. Okay, and I know that the answer is going to be of the form u plus t v, because this is the form of a parametric equation. And I know that u is like any vector on the line, so I can choose any point on the line for u, and v is like a vector in the direction of the line. So for example, I could choose this one here to be u, and this one here to be v. Okay, this is the geometric way of solving this. So if this was the case, then I would have that u equals 2, 3, and v equals, well, just work it out. What is v? It's 1, 2, 3, comma -2. So that means the parametric equation of the line is 2, 3 plus t lots of 3, -2. Okay, and that's a perfectly good way of answering the question. Okay, if you didn't want to do it geometrically, you can do it purely algebraically. You can say something like let u be equal to either one of these vectors. It doesn't matter which one. So I can let u be equal to 2, 3. And now I want to solve for v. Okay, I want v to be a directional vector. So I could try and solve an equation of the form u plus v equals the other point, 5, 1. So u plus v equals 5, 1. What this means is that v equals 5, 1 minus u, which is 5, 1 minus 2, 3, which is 3, minus 2. And that's the answer. So I get the same answer again. 2, 3 plus t lots of 3, minus 2. The exact same answer. But notice, there's no reason why I had to choose u to be equal to this vector. I could have done this same question and let u be equal to 5, 1. And now you would have u plus v is equal to 2, 3. So this means that v is equal to 2, 3 minus u, which is 2, 3 minus 5, 1, which is minus 3, 2. So a parameterization is 5, 1 plus t lots of minus 3, 2. This is correct and this is correct. Even though they're different numbers, they both describe the same parametric line. Okay, so this is how you find the parametric equation of a line if you have 2 points. This is the geometric interpretation, which I think is useful for you to know, but you can do it purely algebraically as well. That's the end of this example, and that's the end of this video.